Let's work with complex numbers and radicals. For example, let's multiply these two numbers. Now we're going to be using the following property here, that for any positive real number a, the square root of negative a is equal to I, the imaginary unit, times the square root of a. That is, this is equal to I times the square root of 3 times I times the square root of 12. And then combining the i's, we have I squared times the square root of 3 times the square root of 12. And now combining the radicals, we have I squared times the square root of 36. But remember that I squared is equal to negative 1, which we can use here. Therefore, this is equal to negative 1 times the square root of 36, which is 6, or negative 6, which would be our answer. Now, we have to be very careful here. When a and b are both positive, then the square root of a times the square root of b is equal to the square root of a times b, which we just applied over here, didn't we? That the square root of 3 times square root of 12 is square root of 36. But when a and b are both negative, we cannot use this property. Watch what happens if we try to use it from the very beginning. What would we get? We'd have the square root of negative 3 times negative 12, which is the square root of positive 36, which is positive 6, not negative 6. So be really careful here. All right, let's look at another example. Let's multiply and write our answer in standard form. Again, we'll be using this property here on each of these square roots. That is, the square root of negative 4 by this property here is I times the square root of 4, or 2i. And what about the square root of negative 25? This is equal to I times the square root of 25, or 5i. And putting these into here gives us that this is equal to 3 minus 2i times negative 1 plus 5i. And now we can FOIL. This is equal to 3 times negative 1, which is negative 3, plus 3 times 5i, which is 15i, and then plus negative 2i times negative 1, which is positive 2i, and then negative 2i times 5i, which is negative 10i squared. Again, we're going to be using the fact that I squared is equal to negative 1 here. That is, this is equal to negative 3 plus 15i plus 2i, and then minus 10 times negative 1, which is positive 10. And then combining like terms, we have the real part is negative 3 plus 10, or 7, plus the imaginary part, which is 17i. And this would be our answer. All right, let's see one more example. Let's divide and write our answer in standard form. Again, we're going to use this property here on this square root of negative 9. That is, this is equal to 1 divided by 2 minus I times the square root of 9, which is equal to 1 divided by 2 minus 3i. And now we need to multiply both the numerator and denominator by the conjugate of the denominator, which is 2 plus 3i. So this is equal to 1 times 2 plus 3i, which is 2 plus 3i, divided by this product here, 2 minus 3i times 2 plus 3i. And now we can FOIL out the denominator, which gives us 4 plus 6i minus 6i, then minus 9i squared. And the plus 6i and minus 6i cancel. And again, we'll use the fact that I squared is equal to negative 1 here, which gives us 2 plus 3i divided by 4 plus negative 9 times negative 1 is positive 9, which is equal to 2 plus 3i divided by 13, and then dividing both terms in the numerator by 13 to put it into standard form gives us our real part is 2/13 plus the imaginary part is 3 over 13i. And this would be our answer. And this is how we work with this property here. Thank you, and we'll see you next time.